today I'd like to talk about fusion of sensor and robot. Let me just start my self-introduction. My name is Haruhisa Fukano from Fujitsu, and now I am working on the business planning and architecture designing around the edge computing. And I am also the member of the technical steering committee in the LF Edge Akraino project. Before start my presentation, I'd like to thank the community members, Professor Shimizu and Jeff, to contribute this presentation and also our community activities. Professor Shimizu is working for the Ritsumeikan University, and he is expert of the robot handling using the electronic device. And Jeff is the CEO of the Signal Logic. He is expert of the signal and image processing. The objective of today's presentation is introducing to our community activity about the robot. And here is the outline of my presentation. First, I will explain the future society from the perspective of the Industry 5. And second, I'd like to explain about the challenges, robot challenges faces in the Industry 5 and its solutions. There is the solutions about for the robot, flexible robot handling called SSES, sensor-rich soft and effector system, and also the lightweight ASR, automatic speech recognitions. And then I'd like to talk about the activities in the Akraino project. We have published our solution as an open sourceware stack to make people easy to use. And then now we are working on the proof of concept in the industry, food factory industries. I will show you that. And also, I'd like to explain about the activities in the future. So as the keynote show you industrial revolutions, the first Industry 1 started in the 1800s with the mechanization using the water and the steam power. In the 1900s, the Industry 2 started with the mass production using the electrical power in the assembly line. In America, the Ford car factory is famous as the Industry 2. And 2000, Industry 3 started with the computers using the robot automated production using the electronic. Now today is the Industry 4. Cyber-physical system is a typical example. The collecting data and analyzed in the AI in the cloud and feedback to the real world. In addition, today is also beginning of the Industry 5. Industry 5 have two key attributes, mass customization and also the human and robot collaboration. Next slide, I will show you the key attribute in the Industry 5. The first is the human and robot collaboration. Human and robot collaboration, this improves the productivity of the complex tasks that now only human can do using robot, combination by robot. And this where we can expect the spread of the robot to the various industries, like agriculture and restaurant and the food factories, like that today's robot can not work. And second is the mass customization. Mass customization is not only automated mass production by robot, but also customization according to the consumer preference. For example, Nike is a sneaker maker. Nike provides you a customized sneaker by the Nike by You. In the Nike by You, you can order the material and also colors of the sneaker, and you can get the customized sneaker from Nike. So mass customization will provide a new value for consumer and also the manufacturer. For the consumer, we can get the customized add value product. For the manufacturer don't have to have extra inventory. They can reduce the inventory. So as we can see from these key attributes, robots plays important role in realizing the Industry 5. So we know robot plays important role in the realizing Industry 5. So can we use today's robot in Industry 5 dynamically? I think not enough today's robot. I will explain the reason from the next slide. Let me compare requirement for the robot, today's robot and the robot in the Industry 5. When today's robot handle the object, object is standardized and uniform, and also field circumstance is stable. For example, in the car factory, the object is a car, is a standard and also uniform size. And also the circumstance of the object is always the same position for the robot. So today's robot, when controlled, are always the same position and the same object. So that the program is will be the simple and simple routine. On the other hand, robot in the Industry 5, the object will be the diverse shapes, the flexibility, and also the frictional properties. Because the mass customization will change the object, depends on the customer preference. And also, please imagine the retail use cases. In the retail, there is many merchandise which is the different sizes and the different shapes. And also, the circumstance around the robot will be ever-changing. Agriculture is a prominent example. Weather is always changing. Then that will be changed. The humidity that will change the frictional properties. So robot will have the challenge about the autonomous handling controlled by the robot in such Industry 5. And also there are other challenges in the Industry 5. Please let me compare where and how today's robot work with Industry 5 robot. Today's robot is isolated from the human, from the viewpoint of the safety. There is some of the fence between the human and the robot. And also, once robot programmed by the human, robot will work the simple routine. In other hand, robot in the Industry 5 will work with the human in the same field with the interactive communication. And also robot will act flexibility by the human orders. So the challenge is the rapid communication with the human. We have the solution for these challenges. For the autonomous handling controlled by robot, Ritsumeikan University research and develops flexible robot handling for various objects and various circumstances, which named SSES, Sensor-Rich Soft and Effector System. And also for the rapid communication with human, signal logic developed the reliable and low latency speech recognition, ASR, automatic speech recognition. From next section, I will describe these solutions. First, I will explain about the SSES, sensor-rich software and effector system. In this slide, I would like to explain how SSES trying to solve the challenges. There are two big approaches in the SSES. The first is the enhancement of the cognitive ability. To enhancement cognitive ability, SSES developed the sensor-rich technology using such composite sensing platform, and also used the AI and IoT technology using the force and contact. Contact is robot contact information, and also IoT maintenance. And second is the new mechanical for the robot hand. To grab the various objects, we developed the flexible manipulators using the polymer materials. To make this hand, we use the advanced 3D printing technology. In this slide, I would like to explain about the SSES from the network perspective. SSES has two data paths. First is the real-time feedback path. This latency is 1 millisecond. Goes to the sensor and the robot control PC and immediately reflected to the robot control. The second path is the IoT data path. This latency is more than 100 milliseconds. This path is used for the analyzed in the cloud and feedback to the robot control. For example, let me show you how to grab the object with the robot using the air pressure handling robot. This robot uses the PID control in the traditional controlled way. The PID control uses the current value and also accommodated value and also the amount value from the past. This value will calculated by the current value, such like the sensor values. So this path will use the real-time feedback path. And also, PID control have the coefficient value, like the K values. We need to optimize these values for the stable PID control. To calculate this coefficient, we collect the data such as the sensor data and result data robot can successfully grab or fail. And also how do we control the robot. And analyzed in the AI, and we calculate the coefficient value and feedback to the robot. And we can use another robot result to calculate these coefficient. So we can use to calculate this coefficient IoT data path, which is a slow path, because this is not needed to be real time. This is the network aspect perspective from SSES. And also, we have developed the RCPS as the mechanism for the collecting data and analyzing data for the SSES. RCPS stands for the reconstructible basic system for the cyber physical system. This enables you to construct and reconstruct the barrier system easily at the low cost. RCPS, there is three main components. One is a multi-sensor module, and also the PDH, like IoT gateway, physical data hub, and also cloud. MSM is the multi-sensor module. This have the onboard sensor and also interface with the external sensors. In addition to that, this have the external output to the controllers. For example, the actuator robot and motor and valve to control this. And PDH is the IoT gateway. This is connected to the MSM sensors, and other sensors, be it Bluetooth and LPWA, and also wired. This have 5 main functions: add location information where the sensor is, and also the timestamp, and also add unit, and also formatting data for the JSON format, and also diagnose the sensors. And cloud have database functions and also data processing and data analyzing function. Fujitsu have developed basic data processing and analysis software in the cloud, for the cloud. You can watch the demo video on the YouTube about the SSES. In this video, you can see how the robot autonomous determine the position of the different tableware and correct them, and also the grab the food. SSES is invested by the Japan Cabinet Office through the CIP program, Cross Ministerial Strategic Innovation Promotion Program, to solve social issues and develop the Japanese economies. From next section, I will describe the signal logic ASR, automatic speech recognition, to realize the rapid communication with the human. Signal logic developed the lightweight ASR engine. This ASR can recognize the agent safety voice command, for example, stop, and also the operating command, for example, change mode. If worker says some commands like stop, the ASR engine inputs to the voice by the waveform, and they analyze using the DNN and XMM, and they output the command by the text, like stop. Signal logic ASR is very lightweight. It can work less than 50 watt per consumption with no fans. And also it consumes only one Atom CPU core, which is the Intel small CPU. And also it is enough word vocabulary to 20 kilo vocabularies. And also it have a noise removal function. It can minimize the robot background noise. For example, servo motors and the wheels. So they are working on the Lumber demo, Lumber proof of concept. As you can see from these pictures, the motherboard for the ASR is very small. So signal logic ASR accurately recognize voice command in the field, regardless of the internet connectivity, because of the onboard SR, and prioritize the human safety. Yeah. And we are working on the open community to publish our solution as an open software stack to make it people easy to implement. And to advance this solution using a community power. Next few slides, I would like to explain about our activity. We are working on the LF Edge Akraino project. LF Edge has several projects. Akraino is the one of them, and provide edge computing OSS stack, which called the blueprint. Fujitsu and Signal Logic and Ritsumeikan bring the SSES, RCPS, and ASR as an open software stack for everyone to use. So we have published the robot blueprint in the Akraino. There are many challenges and use cases for the robot to apply the many industries. For example, how we simplify the teaching to the robot, and also the multi-robot co-working. So it will the combination of the elementary technology. So we launched the CPS robot blueprint family. And now we are focusing on the robot basic architecture blueprint to provide a basic OSS stack based on the SSES and RCPS. This is our robot basic architecture based on the SSES blueprint. This will provide the open software stack for the data collection and the data analyzing and the feedback to the robot control. In the release 6, now is a release 6, we have already published the collecting data. And now we are working on the analyzing data for the December 15th release. And in future, Akraino release 8, we will release the feedback to the actuator and the robot. And we have received the Akraino Awards Blueprint of the Year 2022. I like to appreciate for the community member and its help. So this is the detail of the blueprint in the Akraino release 6. This provide data collection. The documents are available on the wiki page: architecture document, installation, and the test document. So you can easily build data collection function following this document. And this is a detail of the blueprint in the Akraino release 7. It's next release. We will enhance the functionality, data processing, and the data analysis, and also the lightweight ASR. We will enhance the data processing, analysis, and ASR. So, and we will release the basic data processing and analysis software library. Because of the use cases, there's many use cases, and the processing and the data analysis method is differ according to the use cases. Next slide, I will explain about that. So this is the summary of the basic data processing and analysis software which we will release. Data processing and analysis method differ depending on the use cases. For example, there is a various kind of data and various pattern, and we need to remove, for example, we need to remove data when the robot is a standby. For example, this waveform, that this duration is the robot is standby. So we do not need to analyze during this period. So we will provide some library to easily to process and analysis. For example, the split time series data, and also the detect peak, and also calculus, and FFT, and remove noises. So you can easily to process and analyze the data using this library. There are another libraries, so I will publish the document in the Akraino, so please check that. And also we are working on the proof of the concept with the food factory using RCPS. We try to detect the sign of the AGV, automatic guided vehicle cause out, road surface of the food factory is unstable due to the humidity and also the drainage gradient. So it is difficult to operate AGVs stably without the cost out. This is a cost, and sometimes the cost out. We have confirmed that the RCPS and the basic data process and the analysis software can detect cost out indicators. That we have correct gyro data using the MSM module and via the PDH stored in the low database, and we have split the time series data without the robot standby period and overlap to compare that. And finally, we have detect the unusual pattern of the sign of the cost out, comparing the patterns. Yes. As finally, I'd like to explain about our future activities. We will add the feedback path from the AI analysis to the robot actuator and the robot. But however, there is a difficulty about the interface with the robot arm and hand because there are the various kind of arm and hands depends on the use cases. For example, there is a hand controlled by the air pressure and or the motors. And also arm, about the arm is a very kind of the arm. For example, there is a many motors, number of motor is different. So we need to absorb the difference of the hardware. So far now, loss 2 is a candidate to the solution. Now we are working. We are looking for the blueprint collaborators, so we are welcome to the participants. Please contact me. Finally, let me introduce the LF Edge industry solution showcases. Now we are exhibiting several edge computing use cases in the industry, such as the robotics, IoT, clean energy, MEC, retail, factory plant in the One Summit booth. So please feel free to come and discuss about these showcases. And now we will make a presentation in the OSS Japan in the next December 5th. I will make a presentation about this robotics and also the platform to execute these robot applications. To end my presentation, I will sum up our main points. To solve the challenges of today's robot faces in the Industry 5, we fusion of the robot and the sensors. And we published this solution as an open source software stack in the LF Edge Akraino community to evolve these solutions. We are looking for the collaborators in our community, so feel free to join us. Yes, and also I'd like to thank to the Cabinet Office, Japan Cabinet Office, and NEDO and CIP to support this work. Thank you for listening today. Thank you. Do you have any question and comment?
Thank you. Sorry. I'm Hugh Taylor from Edge Site Partners. Just a quick question, and perhaps I just missed this. Is the speech recognition lightweight speech, is that on board on the robot, or is that hosted in edge infrastructure?
Now, on board with the Lumba. Now it's the proof of the concept phases, so that now signal logic add the small board on the Lumba. For future, they will combine the Lumba board.
So the low latency is on board?
Oh, yeah. On board low latency.
Yeah, just on the speech recognition as well, it's kind of probably a problem that has been a challenge for a long time, because even still, I have to change my accent into an English or an American accent to get Google to understand me. So I don't know if we're relying on that to stop something that was going to kill someone. How good is that area still? Or the work seems to be quite slow there still on speech recognition. So I guess the question is, has speech recognition technology moved much in the last 3 or 4 years?
Sorry, could you...
Has speech recognition technology improved much in the last, say, few years?
Sorry, Jeff is the expert of this phases. But I think that he evolved this speech recognition. For example, the remove the noises is one of the aspects of the revolution.
I think it has improved. I think speech recognition has improved a lot. Just from my point of view, AGI, which is artificial general intelligence, is changing recognition process quite a bit, and I think this will kind of solve some of these issues that were brought up, and also some of the problems that you're trying to solve, too.
Okay, thank you. Go ahead. Thank you for your comment. Are there any questions and comments? It's okay?
It was good.
Okay. Thank you for listening today.